Alrighty, thank you very much. Welcome to the West Michigan Azure User Group. The second Tuesday of every month is what it is, so you made it here this Tuesday. Look forward to having you again in the future. It's definitely a pleasure to be speaking with you about Microsoft Fabric. And don't know if that drew you here or not, but you're here and you're here to learn. So I want to just thank you again, Todd Davenport, for having us. It's been a while since I've been here. I did certifications a few years ago in Microsoft SQL Server, so took them here and back here kind of sharing with you what I know about data and analytics, in particular in Microsoft Fabric. I've titled this session An Introduction to Microsoft Fabric because I kind of want to do three things. I want to kind of give a general idea of what it is, why you use it, and then give you some hands-on demo just to give you a perspective of what all it contains so that you have a little bit of familiarity with it. And if you hear people talking about it or just knowing whether you want to use it or not, or knowing what you want to learn more. It's not going to be a deep dive. It'll be more of a breadth versus depth, but hopefully it'll pique your curiosity. Microsoft Fabric was announced earlier this year at the Build conference, and it's still in public preview, so that means they're still updating and developing and fixing things. Even this morning when I logged in from last night, they updated icons on me, so good thing I didn't take screenshots because they would have been updated already within 12 hours. And with that, also feel free to ask questions, particularly questions I may not know, because that means I get to research it and I get to learn, and I love learning, and learning keeps our mind young, right? That being said, I am Robert Hutchison. It's probably a good idea to share a little bit about me. I know Kim's shared a little bit just because, you know, if you went to a mechanic or you're looking at buying a car and you wanted to get advice, it'd be helpful to know whether you're asking a car salesman or mechanic. Give you two different advice. So I am a consultant at 3Cloud. 3Cloud is a Microsoft partner, and we do cloud, app development, and data and analytics. And I've been doing data analytics projects for about 15 years between data engineering, Power BI, and AI kind of projects. And I enjoy mentoring people, so if you have interest in this, please follow up at the end, and love to connect and help advise you any more that I can. So with that, let's jump into what is Microsoft Fabric. And I'm not good at defining things, so I used the next best thing is the Microsoft AI-powered Bing chat. So I asked it, what is Microsoft Fabric? And it gave me an answer, which is good. Microsoft Fabric is a new AI-powered chat mode of Microsoft Bing that can help you quickly get summarized answers and creative inspiration. Not off to a great start. Bing is a little bit optimistic, but it keeps on going, which is good. It is also an all-in-one analytics solution for enterprises that covers everything from data movement to data science, real-time analytics, and business intelligence. Much better so far. That's more of what it is. It offers a comprehensive suite of services, including a data lake, data engineering, data integration, all in one place. With Fabric, you don't need to piece together different services from multiple vendors. Instead, you can enjoy highly integrated, end-to-end, easy-to-use product that is designed to simplify your analytics needs. So a little bit of marketing hype at the end out there, but if I were to summarize this, of what Microsoft Fabric is unified analytics. That's what I'd sum it down to in 2 words. So unifying analytics isn't something new to Microsoft or any other industry, but this is where Microsoft is trying to unify its analytics. So with that, I want to kind of give a little bit of history of like how we got here. Because unifying analytics is a broad term what's a little bit more tangible of why do we need to unify analytics? Hasn't it been done before? So a little bit of history, a few years ago, there's Microsoft SQL Server, and in those days, everything was on-prem, right? There's no such thing as this cloud. And in Microsoft SQL Server, you had, obviously, your query database engine to store your data. You did your data warehousing. But then you also had these components for analytics. Of key components I would highlight is your integration service, so SSIS. You have your modeling service, your SQL Server analysis services, SSAS. You'd also have your delivery reporting, your SSRS. So you had all these combined into one tool. Everything was on-prem. Everything was easy, so it seemed. And then we went to the era of cloud. So you didn't want to manage your SQL servers anymore. So Microsoft SQL Server came along with it in different flavors. We didn't necessarily have the full SSIS, SSAS capability that you did before, but they migrated some of those services over. You had Data Factory, new tools. You also had the era of big data coming in to be a hot topic. So being able to separate your storage and your compute, and then also scale that. So you get all these new tools that operated around data analytics. They're pretty fragmented, and so obviously once things get too fragmented, people start things, I can make things easier by grouping things together. And obviously it goes a little bit diverse ways. Once you group things together, people want, I need a little bit more variety than just a hammer. So that's where Synapse came in. So Synapse took some of those tools like Azure Data Factory, moved it into Synapse pipelines. You had your SQL Server or your SQL data warehouse moved to your dedicated SQL pools. Combined some additional features with the SQL serverless compute options, and obviously when you have Synapse, it forces you to have a ADLS storage account, your Azure Data Lake storage account. Make sure I'm keeping on track here with my notes. So you have all these different services now being pulled into it, but you didn't quite have Power BI integrated into Synapse. And then you also had the issue of the different, how you store files. So you could have your Spark notebooks read and write to your storage account, and it's in its certain format. And SQL Server or SQL Serverless can read and write from that same data store, but it has a little bit different database. But then when you want to scale this up to your dedicated SQL pool, you have to move data from your data lake to your dedicated SQL pool, so you're moving data. And then when you want to build a report, then you move your data then into your Power BI. So you're just moving data, moving data, moving data, which moving data costs time and money. So that brings us to Microsoft Fabric. And for Microsoft Fabric, it's trying to unify three things, in my opinion. The interface, so you have all these different tools to go for ingesting, modeling, and delivering your reports and doing your AI work. It's trying to unify that. It's also unifying how the data is stored and where it's stored, which will help reduce the amount of movement that you have to do, right? If it's all stored in the same place. Kind of what the idea of your lake house is, you move all your data in one place. But also security, which I think will be a very awesome enhancement as well, kind of like unifying the security model around your data. So if you go and watch other videos on Microsoft Fabric, you're probably going to run into this chart or some version of this chart. So I'd like to take a couple moments just to kind of like walk through this and have it explain a little bit more of the components of Microsoft Fabric. So at the top, you can see different services that you had in Azure that now it's bringing those services into one central location. So you have like your data warehousing, your data engineering, data factory, your data science work, real-time analytics, and Power BI. So before, like you'd log into Azure, you'd go to the service, you'd have your different settings there for networking, firewalls, things like that. Then you'd also then launch the tool. So Azure Data Factory would have its own web page that you navigate to, or Synapse has its own web page to interact with. So it's kind of different areas. So this will bring all those services into one pane. But the next big thing it's unifying is storage. So down at the bottom, we have OneLake. And Microsoft is kind of describing that as OneLake is like OneDrive. So how you have OneDrive, you have all your files go into your OneDrive, and it gets synced to the cloud, and you don't have to worry about your ADLS storage accounts. So every tenant will have one lake, not two, not three, just one. And it will manage all of the different storage accounts underneath the hood. So you don't have to worry about which storage account did I put this data in, or let's figure out how to architect different storage accounts to have certain performances if everything's hitting certain data at certain times. But along with that is they're standardizing the data format for your tables. And they're standardizing that to the open source Delta file format. Has anyone worked with the Delta file format before? Has anyone worked with Parquet format before? A few people. So how I describe Delta files is typically Parquet files with a transaction log on top of it. And Parquet files are basically a file type that compresses at the column level. So you have different columns, and it compresses that down for each column, which is a common structure for SQL Server and Power BI. If you look at SQL Server, they have column store indexes, right? So they compresses things by columns. And in Power BI, it has the VertiPack engine, which compresses things by columns. So Microsoft figured out, with a little bit of encouragement, they can have all these different engines read a column store type file, and that they're now all can natively interact with the same files. So that gives you your compute layer, which now can interact with any of the other compute sources. So if you create a table using SQL in Lakehouse or Data Warehouse, you have a table that's in Delta format. The Spark engine can read that table like a table because when it creates a table, it creates it in the Delta format. So it's the same thing. So we now also have a scalable performance solution from Fabric, because now you can leverage the SQL Server Query Optimizer, the VertiPack Columnar Query Processor, and then the Polaris Distributed Query Processor. So kind of like you can distribute your queries, you can figure out how to process your query and optimize that query between the different compute. So you have the separation of compute and storage, but since everything is more standardized now, you can interact with it and still have performance without having to translate proprietary data formats. Absolutely.
I'm an infrastructure guy, so this stuff is pretty much over my head. But are you saying that like at that compute layer, like T-SQL, Spark, K12 stuff,
Yep.
it will ask for the data in the format it understands, and then the OneLake will translate that to what we need and return it?
Yeah, so it is basically, SQL has a SQL endpoint, so a Fabric SQL endpoint. And when it receives a query, underneath the hood, instead of using the proprietary data format that like SQL Server has up to this point, it's now using Delta files. So it's querying the one data lake. These are just files that I'll show you that you can look at using like a OneLake browser, just like you would OneDrive, and you can see all the files that it's reading from. So it's making that connection of a SQL query and translate it to, this is how I read the Delta file. And it,
Just to clarify, so I write it like a normal SQL query and then the backend is doing that?
yeah, so you're just writing a T-SQL query like you would against a table. But you could also use a Spark SQL command, and it's going to translate it the same way because underneath the hood, it knows how to query a table. And then Microsoft in the engine knows how to translate that table into a distributed compute processing.
Okay.
I don't know if I answered that well.
That helps. I was trying to understand that. So at that top layer, we put it in the way we normally do or we're used to.
Yeah.
And then it hits that next layer to get the data from wherever the data lives
Yeah.
and return it
Yeah.
back to that system.
So kind of like a different way is like Power BI. Usually you don't necessarily just query SQL. It's using a different engine under the hood. But since it's now standardized and it knows how to read columnar formats, they can now point at a table, and it's the same table that the SQL was using. So it's a little bit of magic. And along with that is security. We're calling it One Security. I don't think this is fully fleshed out yet, but once you standardize it, you then now, when you have security on your lakehouse table, your warehouse table, no matter what compute service you're using to query that table, it's going to recognize, oh, you only have read permissions, so I can only give you read access to these tables, or you have read-write access. So in a SQL-like manner, those permissions will be managed the same throughout the different data sources. We won't dive into that into the demo, but we'll show the different services and kind of like the OneLake storage account and how to query that data from the different services. Definitely, thank you for that question. Going through all my notes here. Okay. So with this, I think we can dive into kind of hands-on demo, and I can wave my mouse around and show you a little bit of what it actually is versus just talking about it and showing you a little chart and say, this is magic. Any other questions before we jump into that? All right, I've put you all to sleep. Or so we can log into Microsoft Fabric. We'll just start fabric.microsoft.com. And the first thing you'll see is a list of different personas. So Power BI, Data Factory, data engineering, all these different services that they're kind of unifying together. And really what these are navigation items to go to, like items that relate to those user experiences. So kind of like when you log into Visual Studio, ask, what kind of developer are you? That's kind of what it is here. It's kind of like, what type of Fabric user are you? And you can switch between the different experiences down here, whether you have like the Power BI experience, it gives you your reports. If you have data engineering, it gives you the options of the different items that you can create there. What I find myself particularly going towards is more of under the workspaces and just looking at the workspace view, because that lists out all of the different items that you have for a workspace. So things are broken out into workspaces like they are in Power BI. So if you've used Power BI before, this will be kind of a similar feeling of things are grouped by workspace. So here we have a list of all our different items. I do want to kind of break this demo up into kind of different categories that hopefully makes it more understandable, because there is a lot to Fabric in a variety. So if it doesn't make sense, let me know afterwards, because I love to improve how I present these items in the future too. So I'm always open to feedback. So we're going to start out with storage. So kind of like the different analytical items. We had the storage, we had an ingestion or ETL process, you have orchestration, and then you have some kind of reporting or model delivery. So the first category I want to look at is the storage. And so you have lakehouses and warehouses. You also have KQL databases. I'm not going to cover that in the demo because that would make this even longer. And if we go up to here to new, we can see our list of options. We can do a new lake house. In this example, we would do like saline lake house. I'm not going to create one because I already did, so I will pull it up down here. You can see a list of options of what type it is. And oh, I can make it bigger for you. Would you like to squint? So scrolling down here, when you create a lake house, it's going to create a couple other items by default. It will create a SQL endpoint. So that's the SQL endpoint that's going to translate your SQL queries against your data warehouse, against the tables. And it creates a default data set, which gives Power BI the ability to interact with those. It gives you endpoints for those tables, lakehouse tables. So clicking into the warehouse or lakehouse, start out with the lakehouse. You can see tables that have already loaded, buoy data, date dimension, sailing data, storm events. Lake Michigan is not too far away, and I like sailing, so we are going to embrace a sailing-themed demo. So you can see that we have tables here. When you click on them, you can see a preview of the data. So these are tables. And at the bottom, we have files. So not everything is necessarily a table. When you're looking at data lakes, you have other data that are not directly structured tables. So you can load those, and those show up in the files. So for this demo, I loaded their storm data as CSV files, or there's a compressed CSV file, and those can go in a folder structure. And with that, I registered a table on top of that CSV file. And so if we look at the icons over here, might have to zoom in a little bit more for that to see, but we have some different icons here, and those kind of describe what kind of tables they are. So storm events was a table created on the CSV file, and that just has a little grid. But you see these other tables have triangles, and triangle is kind of an icon for delta. So when you see a triangle, the table means it's a delta file that's sitting underneath there. That also means it's a managed table as well. So looking at a little bit even closer than that, we also see a link icon, which means this table is a shortcut. So we talked about moving data is expensive and time consuming. So one thing that Microsoft has implemented with Fabric is shortcuts. So just shortcuts like you would on a desktop. If you're in the 90s and had a massive amount of shortcuts on your desktop, I don't know if people still do that or if people have gone away from that, but it's kind of a similar concept of you go in here to your tables and say, I have data already built out in a table from another business unit, and I would like to utilize that table. And I don't want to have to actually write an ETL process to ingest that here so I can do a query to join those two tables together and get my analysis done. So you can create a new shortcut, and it creates a metadata link to that table. And since it's in one lake and it's in Delta format, it can point right to it, and it can operate it as if it's a table in this database. So when you've all hated people for writing cross-database queries and like, what's going on with my networking and all these queries are cross-database, now you can write cross-database queries without a problem. We can promote bad habits. No. So this is linking to data table from another data lake or data warehouse.
Do you typically just read information in those tables, or do you write to them as well? This type of service.
You'd primarily read them, but allows you to. I haven't actually dug into that.
I'm just curious, like the linking stuff is curious to me because I understand the database side more as the read or write side of it, but for analytics, it's probably mostly read.
Yeah.
I'm just curious if that treats it like I can do a write and it actually writes to it wherever it lives.
As a consultant and an optimist, yes, you can you can write. But I will need to dig into that. Theoretically, it should be able to because it's reading and writing a Delta file underneath. So if you're reading or writing to that, as long as your SQL query inserts the data and it's a proper SQL statement, or if it's a proper data frame Spark statement, then it should. Yes, so that's where the one security kind of comes into play is I might be able to link this. So I have users that can query my lakehouse, but if they don't have permissions to that table, they just won't be able to query data from that table. So even though I've added a shortcut here, its permissions lie within at that table level. So whatever engine is querying it, we'll respect that.
A couple quick questions about the Delta tables. So you said that they were based off of your Delta files.
Yep.
So being Delta files, does that mean that it doesn't store an entire history and it really is just a change that occurred from point A to point B? And then also, because there's obviously some processing that's probably involved in order to make these Delta files for Fabric to read. So from that perspective, does that mean we can't do like real-time data sets, like querying, connecting to an actual database, a live data set?
Yeah, you can. It does log the transactions just like you would any other Delta format. So I'll jump into kind of like the one lake. That is really small for you. See if I can zoom in. So just kind of like you do in OneDrive, you have a piece of software you can install that's called OneLake. And you'll see a list of folders here that are broken out by workspace. Keep on zooming in here. And then it breaks it down by database or data lake. And then it groups it in by files, tables. And you go into like tables, schema, and then you can actually see the Delta files that are underneath. How Microsoft manages those Delta files for their Lakehouse and their like SQL endpoint and Power BI, I'm not entirely sure, but you can take Spark and truncate your history and merge those all into one. I don't know if that kind of answered your question or not. So you can kind of manage how much history is stored as well. You can have service like Databricks and manage your Delta files like you do there, and then you can just point these sources to those files, and it will just read out of those. So as data is entered into that data lake, it will show up. Sweet.
I gotta add on to what Matt was asking. So just for my clarity, are the Delta files a file format, or are they actually files that log the Delta changes?
So it's a file format, and it's kind of composed of two things. It's composed of the Parquet format. So if we jump into here.
So yeah, you were mentioning that earlier. I apologize.
Oh, no, it's right. There's like a actual Parquet format, and it can be multiple Parquet formats, because like if you're merging, it'll add more data to it, right? And it'll create different files. Because the Delta format is ACID compliant. Don't quiz me on which each of those are, but it is ACID compliant like a database. And then there's a log file here, which apparently won't show me, that keeps track of just kind of like a transaction log. When you do a merge statement, it logs the merge statement, and here's the data. So you can actually do like a describe history or show history on a table, and you can see at certain points when data was inserted or merged or deleted. And you can actually select if that history is still there. Select star from table as of version 2 or as of January 1st, 2023 kind of thing. So you can actually do time travel with that. So it uses the Delta file, the log, to figure out like these rows did not exist at that point in time, so we're not going to return those in the result when you do that time travel.
Okay, so if I'm understanding it then, so the Delta files are kind of like the interface between the application and then the Parquet files are like the ultimate truth when the Delta files have that logging as well.
Yeah, so the Delta file kind of tells how to read those Parquet files. So kind of combine that. You can read those Parquet files directly, but you're probably going to get like either duplicate results in there or things like that, unless you kind of coalesced it and rewrote it into like a single Parquet file. So yeah, these are great questions. So that's a lake house. You can see that there's like tables and files, and lake houses have two, like a database name and table name. We're going to jump over to a data warehouse, and you create it the same way of going down here and creating a new warehouse. But I have one created already. I'm going to zoom back out for a second here and look at this saline warehouse. And in the saline warehouse, you can see a little bit more typical structure of a SQL database. So you have schemas, tables, and then views and functions and stored procedures. So in this case, we have a date table. So this is where I got the date table from, did the shortcut. And I populated that by a stored procedure, and you have saved queries down here. So just like you would in a T-SQL statement, you have create or alter stored procedure, give it a stored procedure name. You can go through, create a table. I'm querying data out of the data lake because I can do that. Why not? It's great for a demo, maybe not most organized for a real life scenario. Just pulling in different information and creating a table. And then you'd execute the stored procedure just like you would a normal stored procedure in SQL Server of execute stored procedure name. And that gives us the date table. And then I already showed you the like where it stores it at using the OneLake browser. So that's the lake houses and data warehouses. I'm going to move into the ingestion step. So we have kind of like your storage, your ingestion, your orchestration, and then your reporting. So for the ingestion process, obviously, we have a stored procedure here that is one option of loading in data, but not everything is always going to be already in your lake to run a stored procedure against, right? So that's where some of these other tools come into play. So one thing we can look at is data flows. So if we jump back to our workspace here, and also as a note, in the side here, it keeps a list of like all of your open items that you can kind of like toggle between through like tabs. So you can either keep them open or close them, however you like to manage your workspace. So we are gonna look at data flows. So for example, for this example, with the data flow, if you're familiar with Power BI ingesting data or how you pull in data with Power BI using the M engine, this is going to look pretty familiar to you, where you have your like applied steps on the right here. You'd go through and get data from different data sources. In this example, I have an Excel file sitting out on SharePoint, and all it is just a quick sailing log of here's the dates I sailed, how long, and how far I sailed. You can see the different steps of promoting headers to be the first row or its headers, change column types, things like that. A very simple demo here. But then you choose your destination down here in the bottom right-hand corner. In like our case, we want to read this data from Excel file in SharePoint or anywhere else into the lakehouse. So we specify what connection. We're going to go to a lakehouse. Next. And then it will give us a list of the different lakehouses we have available. You find your workspace, go down to the lakehouse, specify, I want it in the sailing table. And then you can define whether it appends or replaces that data. In our case, we're just replacing that data. And then once you hit publish, it will save this and run it and ingest the data for you. And that's a one-time thing, and we'll talk about orchestrating it and having it run on a schedule in a moment. So now we have a date dimension. We have sailing data as well. So every time, close this. Yes, I want to exit. Another way to ingest data is using Spark notebooks. And Spark requires a cluster to run to do the compute. So a notebook is just kind of like a sequence of commands that can be either Python, SQL, Spark SQL, or PySpark as well, R or Scala. And you can use those languages interchangeably depending on what you're most comfortable with. And you can, if certain areas are easier than others, do that. Microsoft also listened from Synapse, where startup times for the Spark pools took a couple minutes. Now they take in the matter of 15 seconds or less. So here we're reading buoy data. So there's a buoy that sits a couple miles west of South Haven, where I sail at, and it records wind speed and water temperature, things like that. So we're gonna start a session here. This buoy ID is named that ID. If we had another buoy data we wanted to pull in, we could parameterize this and pull in tons of different buoy data. Pull it from NOAA, and we're using PySpark here to download the data from a text file and process that into tabular structure. And then we're going to clean up the data, kind of like we would in an ETL process. So this data has, when it doesn't have data logged for it, it just puts MM, which MM causes lots of problems when you're trying to do averages and sums. So we're just going to replace those with null values for all of these different columns. So it's a just tidy little with column, replace this value with this in all these columns. So pretty easy to do with PySpark. Then we're creating a temp view here, so then we can switch over to T-SQL. And we can run a query against that and see, just running a normal select star statement, we've now are reading from an Excel file or a CSV file. And then we can create another temp view using more ETL kind of logic. I won't bore you with the details. We can select from that as well. And then we can create a table in our lakehouse. So using a create table statement, we are going to specifically specify using Delta. So that way we have it in the Delta format. And then we're going to run a merge statement into that target table from our temporary views that we've created. So now that we've run through all of that, you can see that it do a merge statement. And now we have saline data, a date dimension, and we have buoy data. One other, to keep on going here, way to ingest data is using the copy task from a data pipeline. So if you're familiar with Data Factory, this is a same concept as Data Factory, but now it's in Fabric as well. So you have different activities that you can run that will copy data. So now we're going to pull in some storm data. So when did it storm on Lake Michigan? That might be important if you're sailing, right? And so NOAA has a data source for that as well. It's on an FTP server. So let's pull in a connection to an FTP server here. If it was a different data source that I was pulling from, you can do a different connection. And like Data Factory, there's different data sources that you can pull from. And then the other component of the copy data task is you've pulled the data, where do you want to put it? And in our case, for this demo, we're putting it in Lakehouse, but not a table, because that would be logical, but we're doing files for a good demo. So it's going straight to a CSV file, and that's what we kind of showed you earlier. So it writes a CSV file to our Lakehouse, and we can run this just by going over here to the Run tab and then Run. And then obviously, if this was a single thing, you can obviously schedule it to run at certain times. But now we have just like a CSV file. What might be handy is to actually query that as a table. And how I got that external table, so if you have tons of CSV files, you just can create tables on top of it by using a Spark notebook that does a create table statement. Using CSV can give first rows headers or other options in there. And then you just point to the file location. So since we have the Lakehouse linked over here in our resources panel, we can just reference the files /staging/ whatever structure I just saved this in. And that gives us that storm events data. I wanted to call that out because when you create tables this way, they're not Delta tables, so they're not available in the data sets for Power BI or SQL endpoints by default, or at all, at least at the moment. That may change tomorrow, who knows? Is that kind of making sense so far? Different ways to ingest data. So you have stored procedures, data flows, Spark notebooks, and data pipelines.
Robert, the data pipeline, that was very reminiscent of SSIS.
Yes.
A replacement?
Yes. Well, I don't know if they would say replacement. They keep on dragging SSIS along. But yeah, when they went to the cloud, they introduced a Data Factory version 1, which hopefully no one has ever used, because they quickly came out with version 2, which was much better, because they actually made it usable, which was great. And that's basically like the SSIS version in the cloud. Even though Data Factory, you have the ability to run SSIS packages in Data Factory, although I think it's rather expensive and requires a lot of work. So I'm a consultant, so I bring people onto new services.
Have they talked about migration path from either Data Factory or Synapse into Fabric?
Yes, that is a great question. They get it a lot because obviously they've been building up Synapse so much. If you use analytics, you should be in Synapse, and for good reason. Their message is Synapse is not going away. It will still be there, but they're also building tools to easily migrate that. So I imagine, and a lot of it will be a pretty easy lift and shift. I imagine, I don't expect it will be very hard, but I think they're trying to nail the, let people come in. So they're building out a process, I think, to make sure that they have the story easy to move Synapse to Fabric. And this is still in public preview, so it's, it may just magically show up in Fabric, who knows. Don't quote me on that. I don't work at Microsoft.
I'd rather fully baked before we try to start moving into that.
Yeah, so Synapse will stick around from what I'm told, and so it'll probably, once they're sure everything's fully baked and ready to use, it'll be a pretty easy migration to Fabric.
You know, what you'll probably see is this will go, once this goes to GA and people start adopting it, then Synapse will stop getting invested in, and the writing will be on the wall, but nobody will tell you that, and eventually you have to move over.
Yeah.
And then no working on it.
So with that, scheduling, we only have a few more minutes, right? Yeah. Scheduling, so we have all these ingestion processes. Obviously, we want to be able to run this without having to run each step manually. So that's kind of like an orchestration tool. So you use data pipelines for that. So opening up this pipeline, you can see that just like SSIS, you kind of have different activities. So we're calling it the data flow. Then we're calling a notebook. Kind of those can be called in parallel. And then stored procedure depends on those steps. And then zoom out a little bit here. You can invoke other pipelines as well. And you can send things like emails and even send team messages. So if you want to send messages to your engineers that are supposed to be developing this, you can have direct messages to them, whatever one wants. But different ways to orchestrate this. So this would orchestrate this all, and then having it scheduled obviously is a big thing. So just like Data Factory has the ability to do different schedules, turn it on and off, run different days of the week, certain days of the week, at certain times, start time, end time, so that this data pipeline will run on that schedule. So trying to wrap it up here with, so we've looked at the storage, the ETL process, the orchestration of that ETL process, and looking at data. You can do that in different ways. We'll look at the notebook. Although you've kind of already looked at this, we've opened up a notebook, and you can see that we've written queries before. And you can see that we're joining the date table with the sailing table, with the buoy table to get some information We can select that. And if we're doing kind of like more ad hoc reporting, we can, when we get a table here, we can use this chart option. And over here on the right, we have view options, and we can change that chart around to see what we want to see in bar charts. You can also use custom Python packages or R packages to build your charts as well, if that's something that you're more familiar with. So if you're coming from like RStudio, building charts out there, but you need a more scalable solution than just running data on your desktop, you have R that can operate in these notebooks and build out your charts. Another option is directly when you're looking at the SQL endpoints. So let's look at the Lakehouse, and we'll go open up the SQL endpoint at this time. Because this will kind of do two things, which I haven't touched on yet. So it loads. Obviously, Delta files don't have referential integrity or foreign key relationships built in, but you can add those relationships between the tables when you're connected to a SQL endpoint and going over down here to model. And just like you would in Power BI, be able to link tables together and create those one-to-many, many-to-many relationships. Obviously, star schema is preferred coming from the data warehouse realm. No snowflaking. It's still autumn, so. So you can build out your data model here. You can add measures as well. So we calculated a sailing speed of the distance for a trip divided by your sailing speed to get, or time sailing to get your sailing speed. But if we go over here to queries, you can see a query here. And if I'll run that, zoom out just a little bit, that we're querying multiple systems, like the date that sits in our data warehouse. We are also querying sailing, which sits in our lakehouse, and the buoy data, which sits on our lakehouse as well. We get some information here. And if we select this query, we can click visualize results, and it'll confirm this is the query we want to visualize results on. And we bring this up, and we can see a familiar interface if you've worked with Power BI before, and you can visualize the results. And you can look at average wind speed by month name, something like that. So Power BI is probably where you're going to generally see your data at. So instead of just using this little haddock query to use this single query of data, let's use the whole list of tables that we loaded into our lakehouse. So if we go into the data set, so down here we have a default data set that we created. You can see kind of like what it relates to, and then you can create a report off of that. I already have a report, so I'll pull that up and see if it loads. I almost broke this right before I came up here to give a demo, so hopefully it's still working. So this is just kind of like a Power BI interface. So we have different pages on the left here. If we wanted to edit this, you go over here. You don't need to save whatever changes we did. And you can see that pulling in data over here to build out our chart. So this chart is wind speed and wave heights together. So obviously, the stronger the wind, the stronger the waves. Surprise. Here's another tab that's just showing the time, distance, and the speed. So here's the speed. A little bit less than 3 miles an hour. And then combining the data from the lakehouse and the warehouse together. Obviously, these aren't pretty graphs. I just threw them together for demo purposes. But I think what we can conclude about these charts is that Microsoft delivers more that are quicker than I can sail. So that's all I have for demo. I'll stick around for questions as you have them. And thanks for coming out.